All right, hello once again, Jeff Scott of Rankin Technical College, and I've been going over databases with you in this set of videos, and I'm going to quickly talk about Chapter 1 in our Beginner's Guide to SQL 3rd Edition. And as I go through each one of these, I want to go over and explain which one or what the particular chapter is about. This is Part 1 of the book, which I think is the first 5 or so chapters. First 6 chapters. So Chapter 1, Introduction to Relational Databases and SQL. This chapter introduces you to relational databases and the relational model, which forms the basis for SQL. You will also be provided with a general overview of SQL and how it relates to relational database management systems. So I want to do that before I go over every chapter. It keeps me clear as far as what I should be handling, and it gives you a little prelude as far as what to look for. So we're in Part 1, Relational Databases and SQL. All right. And that said, we are going to now start on Chapter 1. Now what I've done, and you may occasionally hear a little noise behind me, I have read all these, but I printed out paper copies. So I'll occasionally be perusing my way through my paper copy, which I have read and annotated with underlining. All right, so Chapter 1, Understand Relational Databases. Remember, SQL is kind of the driver for all this. And if we looked at some of the major relational database management systems, like Oracle, MySQL, SQL Server, etc., those are subsets of SQL, the structured query language. So as it says, SQL supports the creation and maintenance of the relational database and the management of data within that database. Then the author says he wants to explain what he means by the term database. All right. And he says there are many definitions for the word database. All right. Most sources agree that a database at its very least is a collection of data organized in a structured format defined by metadata. That metadata is what I call a schema. We'll get into that more as we go on in here. Over the years, there have been hierarchical databases and network databases, but probably for about the last 45 years, the major database that's been in play has been the relational database. One reason for that is the relational database, all right? One reason for it is the relational database is independent of the application that's using it. The relational database management system is based on the relational model. The relational model was created in about 1970 by a guy named E.F., known as Ted Codd. All right? And a lot of things to say about this. But before we do, again, I mentioned this in one of the earlier lectures. I want to say it to you again. That is the fact that think about how many things that were used in computers 47 years ago are still in use today. If you look at how computers have changed over the years. But really the relational model, which was started in 1970, is still around today. Now, this was defined as a mathematical model, but the key thing is what's shown here in blue. He defines a relational data structure that protects data and allows data to be manipulated in predictable ways that are error resistant. All right? So it uses the mathematical principles of set theory and logic, and it supports, here's a key one, it supports easy data retrieval. It enforces data integrity. We're going to have a whole chapter where we get into that. And as mentioned previously, it provides a database structure that is independent of the applications accessing that data. So at the core of this, as mentioned on the bottom of the page here, going on to the next page, is the relation. Again, this has mathematical roots. A relation is a set of columns and rows collected in a table-like structure. And it deals with each table ideally represents a single entity. So what's an entity? Well, back in the olden days, not so much anymore, but back in the olden days, an entity was defined as a noun, because a noun is a person, place, or thing. But that definition has been expanded upon over the years. So now an entity is a person, place, thing, event, or concept. So it can be something intangible, like a concept. Now there's an example here. This is a relation. This relation has 3 different tables in it. In fact, this says one table. That's what the author's, for now, referring to as a relation. There is one table. It's not set up well. We're going to get to why as we go on. But there's an artist's full name there, as you can see. Sorry. So there is an artist's full name. Why is this a bad relation? Well, first of all, at a minimum, that name should be broken up into 2 different fields, first name and a last name field. All right? So there's a full name field, there is a CD name field, and there's a copyright year field. All right? So why did I take the time, to even go over that? Well, one of the things that the author mentions here is the distinction between a domain and a data type. The data type for this, all right, if you make that numeric, then that's the data type, some kind of a numeric, maybe an int, an integer for whole number. The domain is the list of viable years. And if we say, for example, let's just assume for a second that the first CD came out in 1990. I'm not saying it did, but let's just say that it did. We don't even want the year the CD came out, we want the copyright year. So let's say that the first song or the first CD that's out there was copyrighted. Let's even be a little nuts here. Let's say it was 1900. All right. Then the actual domain for the year would be 1900 through 2017, the current year. All right. We'll talk about data types more in Chapter 3. We'll talk about constraints more in later chapters. So, as shown here in the picture on the bottom of the page, data is stored in a relation. Each one, so this whole thing right here is called a relation. Typically today it's called a table. Each row in the table is called a tuple, typically known today as a record. And each column that's in here is known as an attribute, or typically today known as a field. And all of that stuff is mentioned here. In fact, they mentioned it, I think, in the note that's up on the top of the page here. That's really and truly not that important, but at least you've seen it, you've had an initial exposure to it. Okay? All right. Next, the author goes off and talks about normalizing data. All right? Well, one of the things that we just looked at in here was this. And this doesn't look like a bad relation maybe, but again, I would have to do a lot of work if I wanted to be able to sort this by a person's last name. I'd have to figure out what their last name is. Kitaro, does Kitaro even have a last name? Is Kitaro a first name or a last name? What if we have a middle name in here? What if somebody puts in last name, comma, first name? So we would at a minimum split this out from artist full name to artist first name and artist last name. And or if we had to in a middle initial or whatever, if we had to do that. All right? Although it's not shown here, it's not inconceivable that you could have two CDs with the same name. So technically, this is set up poorly, and there's really not even enough information in here. You're going to see that in just a minute when we talk about normalization. I didn't know this before, but they mentioned that normalization was actually a kind of a joke because when COD was developing this stuff in the early 70s, Richard Nixon was in the middle of normalizing relations with China. So they took normalizations to another level, I guess, and said, well, if you can normalize countries, you might as well be able to normalize database relations. Normalization is a set of rules that are referred to as normal forms. COD identified three normal forms, those being first normal form, second normal form, and third normal form. Since then, several other normal forms have been added. Fourth, fifth, sixth, and seventh normal forms, and BCNF, which is Boyce-Codd normal form. All right, we're not going to talk about any of those. We're just going to talk about the three normal forms because they work for about 99% of the time. So the first thing that's mentioned here is choosing a unique identifier. And that's a primary key. In fact, I've defined a primary key previously as a unique record identifier. So the first step is to select a unique private key. And ideally, that private key will be a single field. Sometimes it'll have to be a combination of fields, and we'll get into that in later lectures. Sometimes you don't have a field that technically could be a primary key. You may even think that with what we had here. So then you come in and you add another field. So we could add another field here and call this, I don't know, artist ID or something like that. And it just would be a number that we would associate with each record. Now, sometimes you go in the other direction, and you've got more than one field that could be used as a primary key. You really shouldn't use fields like social security number or employee number as primary keys, even though people do. But let's assume that somebody didn't know that, and they had a table that they just created, and that table had in it both social security number and employee number. And they were confused as to which one to use as a primary key because technically you should be able to use either one. Since there are two fields that could technically both be used as primary keys, they're called candidate keys. So you choose one. Now, if that was me, I would choose neither one. And again, I would make a field called something like employee ID, and that's what I would use. All right? And we'll talk about it more and more as we go on. Again, typically during the first step of normalization, okay, you set up a primary key. So the author says here for first normal form, it's the foundation for second and third normal forms. So each attribute of a tuple or a record, so each record must contain only one value. You can't have what are called repeating groups. We'll get into that as we go on. Each tuple in the relation must have the same number of fields or attributes. Each tuple must be different, so there must be a way to distinguish between every record in the table. All right, so notice what the author has started to do here. This violates first normal form. There is not a field here. There is not a field here that you could use that's unique. You can say, well, what about these? Well, it'd be possible to have another artist named Jennifer Warnes or Joni Mitchell or whatever. So that's one thing. The second thing, notice here we've got for the artist name, we've got all three of them. No, remember, each field should hold only one value. This one holds 3. This one holds 3. So we're breaking rules all over the place here. So when you normalize, instead of having one big table with a lot of fields, you end up having a lot of different tables, each with hopefully a small number of fields. If you look in the example here, you'll notice that we now have 3 tables. An artist table, a CD table, and an artist CD table. If you look, forget about the middle table just for a second. But this has every artist along with an ID number that signifies that artist. This has every CD name and copyright year, and this has an ID that goes along with that CD. Now, as of right now, forgetting about this middle field, if we just had artist and we just had CD, there are no fields in common between those two. So if we wanted, in this current setup, if we wanted to write a query, which we'll be getting to shortly, where we had every artist's name and their CD name, we couldn't do it without this middle table. And the reason that we couldn't do it is what we have right now are two different tables, both of whom are totally legal and legit the way they are, but we don't have a field in common between these two, so we can't do what's called join these two tables. So we come in here and we make a new table, and we put in what would be the primary key of the artist table and the primary key of the CD table, and we call this a junction or a join table. We could have other fields in here, we don't. But now we have our relations are in first normal form. Not only that, every primary key that's in here for artist and for CD, both those primary keys are just one field. And of course, this one is two fields because it's the concatenation of these two primary key fields. Little tough, maybe to swallow when you first look at it, but it really and truly does make sense. All right. If you're in first normal form, and if your primary keys are a single field, you're probably already in second normal form. Second normal form implies that you are in first normal form. But second normal form deals with what's called functional dependence. So if we look at this, we can say that artist name is functionally dependent upon artist ID. We can say that the CD name and the copyright year are both functionally dependent on CD ID. Looking at it another way, we can say that artist ID functionally determines artist name, and CD ID functionally determines CD name and copyright year. If we have it set up like that, if we have that functional determine, we're in second normal form. But suppose here we had more information. So suppose we had an address, city, state, and zip. If you have somebody's zip code, you can typically figure out their city and state based off of that. So what we might do is we might, when you've got a field that's not your key field, so if you've got a field that's not your primary key, and you can figure out other values based off of that field, you're not going to be in second normal form. Because the only thing that should functionally determine the value of a field in your table is the primary key field. And that's what second normal form is all about. Now, did I say it as well as the author does? I'm sure I did not. Then you go to third normal form. Whereas you get into first normal form, then once you're in first normal form, you can get into second normal form. So in other words, second normal form implies you're already in first normal form. Third normal form implies that you're already in second normal form. And they give an example here, so they've added another field to this artist ID, artist CD table. All right? And what they're saying here is, well, does the artist and the CD, does that imply the copy year? Technically, it does not, because if I have the CD ID, I can figure out the copy year. So in other words, CD ID functionally determines copyright year. Artist ID has nothing to do with it, so I'm already in violation right there. But, so that violated second normal form. Here's something that violates third normal form. All right? If I have an artist ID, I can get their name. Not a problem. But this agency state can be inferred from agency ID. So I've got a non-primary key field that is functionally determining another field. And that's typically referred to as a transitive dependency. So that is illegal. So I'd have to break that up into multiple tables. All right? This stuff's heavy. And I'm not going to try to say that it's not or imply that it's not. I'm going to stop right here and pick it up on the middle in your book of page 11. So following along here, this is page 30 in here, but it's really page 11 of the book. And we're going to talk about relationships. We'll do that shortly.